welcome to a video. In this episode of Makin It Work, I'm going to take a crack at this Califone magnetic card reader. I'll talk briefly about kind of what it does and all that. Obviously it's not working. I bought this off Facebook Marketplace in a really rough state for I think $25. And it also came with a pile of the magnetic cards it uses. These guys. If you're not familiar with a card reader, basically it's got a magnetic strip on it, which is practically identical to the magnetic strip that you would find inside of a cassette tape. Basically it will be driven through a tape head over on this side to record and play back. And the concept was these could be used for schoolwork, something like a language class where you might, need to say something and then have the teacher review it later. So the idea would be there's a teacher and a student button, and this swaps between what we would normally think of as the stereo tracks on here, right? The left and the right. Instead, this is a mono device, so it uses one of the channels for the teacher and the other one for the student. Basically, and that allows you to put two different recordings on the same card. That way the teacher could do, for instance, a Spanish class, they could do pronunciation of a vocabulary word. The student could listen to the teacher's recording and then record their own recording on the student track. It's also got a built-in mic. Now, the interest in this for me is these are really cool devices for making like lo-fi samples. They have a pretty wild sound to them. For example, Heimbach has an amazing video demonstrating one of these. I'll link that below so you can go take a look at what this thing is like when it works. We're going to take a crack at fixing it up. Now, I've already removed the back panel. I do have it. I just removed it so that I could lay it down flat and show you all the control surface. As I mentioned, this thing is in a state. I was not able to do that without removing the back panel. So here's what it looks like on the inside. Now, the first thing that jumped out at me right away were these leads. Someone has, I think in an attempt to repair this, they've jammed a capacitor in here and bent the leads around, but they didn't solder it. It's just sitting in there loosely. One other downside of the state of this machine, I did not get pretty much any of the hardware that holds the case together or that holds the circuit board on. Fortunately, I do have this one screw that I was using just so I could show you all the front panel, and hopefully I can use that to find suitable replacement screws for the rest of this thing. There's kind of the mechanical guts of it. As you can see, we've basically got this mechanism will be really familiar if you're into tape players or have worked on those before. For all intents and purposes, we've just got a motor driving the card through a tape head. Over here we've got our AC power supply stuff that we're going to stay away from. This switch here toggles between going full and half speed. It's normally under the battery compartment and accessible from the back. The idea being the teacher would set this and the students wouldn't have it on the front panel to mess with. But for our purposes, once we get it working, we may relocate this to the front. That way we can more easily change the speeds. Let me rotate this so we can get a better look at the circuit board. So taking a look here, this is our big dangling capacitor. The downside of this thing is that I don't really know what the value is supposed to be. So looking it up online, I couldn't find a service manual or anything. So I think I will maybe just kind of trust or hope, however you want to phrase it, that this is the right value for this spot. And it's a big capacitor there. Then the other thing I noticed by taking an initial once over with this board is this capacitor. Let me try to get a good shot of it. Yeah, this capacitor here, you can see the top has bulged out and split, which is usually a sign that that capacitor needs a replacement. So, probably need to replace this guy as well. One thing that kind of raised my eyebrow is this is the exact same value as our loose capacitor, the 2200 UF 25 volt. So I don't know if that means someone who was trying to repair it saw this guy and just thought, hey, that's a good thing to try. I'm not sure about the deal. But fingers crossed they have the right setup for both. Now over here, I've got 2 trim resistors. They're labeled full and half. So I think these will basically change the speed for full speed and for half speed. So that may be another interesting mod if we get this thing working, is to bring out these. So instead of making them trim pots, we make them just fully accessible pots from the front panel. And that way you can kind of change up the speed how you want. And finally, this empty socket that I actually disconnected to remove the back panel. They were really nice and put in an actual disconnect here instead of making you solder and desolder wires. I've also got this broken wire here, and this is attached to, I'm gently pull this way, it's attached to this connector here, and that connector, basically the 2 white wires coming out of the AC, that runs all the way back to that connector. And one of my wires has been disconnected, so we'll need to resolder that as well. Here you can see this is the white wire coming out of the transformer. This is the brown wire coming off of the board. Those will need to be reconnected. So the first thing I'm going to do is kind of manually. There's no other way. I'm going to remove that loose capacitor. So I've got that taken out. The next thing I'm going to do is desolder the puffy capacitor. It's kind of blown up. So those 2 points here are where that capacitor connects. And based on just kind of the general look of those pads, my working assumption is that that's a big filter capacitor. So we've got a pretty big pad coming in. From around our AC input. And then we've got a really big pad, which I'm assuming is our ground. So I'm assuming that's a big filter capacitor. That said, I'm going to fire up the desoldering gun. I may just fast forward through this segment because it's pretty noisy, so I'll try not to say anything too important during this time. That has really opened up. This is just adhesive that was used to kind of stick it down to the board. See, this is our 2200 25 volt. So it kind of matches this extra capacitor that was kind of floating around in there. I'm just going to use this little tester to see if it looks like that random capacitor is actually any good. That is coming in pretty much perfect, 2200 UF. So all of my 2200 capacitors are only rated for 16 volts. But I've got a 3300 that is rated for 25 volts. In this case, the way that capacitor was blown out, with these looking to be kind of main filter capacitors, I'm not super concerned with the capacity being dead on. I think it can go a bit higher and be just fine, but I do really want to make sure I get the voltage tolerance correct. So I'm going to use the 2200 that came with this to replace the one I just pulled, because it's narrower and will actually fit in this space. This big guy we put in here, because it looks like we've got a bit more room. Yeah, because that is a great big capacitor. Looks like even bigger than that big old footprint. I'm gonna set this to kind of bend over, since we've got a good bit of extra space here. I'm kind of worried about how that might interfere with some moving parts. Let me see what else I have. I don't have any other big capacitors that can handle 25 volts. But what I do have is a 470 ohm capacitor. 470 ohms. 470 microfarad capacitor that can take up to 35 volts. And so I'm going to try out this guy, and a lot of times I might assume that this was just an unused spot. However, it does look like someone has desoldered from here. Just because it doesn't look like completely pristine the way you would expect an unused piece to go. That said, this is a really beat up unit, so really hard to say anything for sure. Basically just did a test fit, and this should fit in nicely, even with the new capacitors. So next step, I am going to get those soldered in. So here comes the fan. Okay, now that I've got that fixed up, our next repair is going to be to reconnect these two wires. So normally I would kind of bend these into like a little hook shape, join them together, and kind of make them, handshake like this, and then solder. But the way this guy's tinned, it doesn't really want to bend. So I may just have to really delicately arrange these. Before I forget, I'm going to put some shrink tubing on here. See, I'm the worst about forgetting to put on shrink tube until it's too late. Okay, get that set up well enough. Here comes the fan. I'm going to shrink that with my heat gun heating. So we've now got our AC power hooked up. We've got our capacitors replaced. Oh, let's go ahead and check this fuse. No, I can't see it as well. Just because I had this blown capacitor, I do want to double check and make sure that fuse hasn't gone. So I've got my hand tester in continuity mode. Oh, cool. And that means we've got continuity across there. So our fuse is A-OK. I'm going to call that good enough for a test. And the clever thing to do would be to test this on battery power. That's less risky than hooking it up to AC, but it takes really big batteries, either C or D cells, and I don't really have any of those handy. I'm actually going to test this on AC power, and if it blows up irrevocably, then, I'll know that was a bad idea, I guess. I heard kind of an initial click noise, but no smoke, no bad smells, always good. Let's try to switch it on. Okay. Hello. Testing 1 2 1 2. That's crunchy hot. Okay, it looks like I put the card in backwards, so let's try this again. Testing 1 2 1 2. Testing. Testing. 1, 2, 1, 2, testing. Okay, maybe I had it right the first time. I'll try that again now that it's taken through. Testing. 1, 2, 1, 2, testing. Okay. So that is technically working. I'm checking to see how much of this I can access from the inside. Okay, well, it looks like I can see the tape head. The tape head under this wheel. I think that's where the tape head and the micro switch that activates the motor. Oh, wait, actually, that is right here. Okay, let me open this point up and see if maybe we can just give things a little bit of a tidying up. There is a pretty big lump in this belt here. And that's because it probably sat in the exact same position for 20, 30 years, something like that. So I'm going to guess that that may have some impact over why our card was not really reliably being driven through. That may just mean we need to replace this belt. I'm being very gentle with it to make sure, worst case scenario, we can keep it on. You can see instead of being round, it's got this point from where it was sitting on this smaller, what are those called? Capstan, I guess. I was kind of hoping this guy would just lift out so that I could get access to some of the tape head. It's a little more complicated than that. Let's take a look at this belt over here. I mean, see, this one's not as bad, but it's still got a similar kind of dent worked into it from sitting for so long. What I have here is just a Ziploc bag full of belts. It's a little variety pack. You can get them off Amazon or eBay or whatever for honestly just a few dollars. Great to keep around just because it comes to a variety of common belt sizes. It usually has something that's like good enough. So for example, this is the replacement belt. You can see roughly the same size. I think it's a little bit thinner, but that's certainly good enough for what we're doing. That might be a little bit too loose, actually. This guy might be slightly smaller. Okay, now that feels like it has a bit more appropriate tension on it. I think this one is a match for our big wheel. It feels like it's got decent tension as well. Oh, I just noticed my camera is heating up, so I'm going to go ahead and break here and be right back. So got these belts replaced, and the next thing I'm going to do, tip it up so y'all can see, but right under here, you can see there's a little lever that moves to click this micro switch right here. And if I'm not mistaken, basically that lever, when the card is inserted, moves that lever forward, push the micro switch, and that's how it knows to keep feeding the motor. So since we were having issues where the motor wasn't running all the way, I'm going to go ahead and just put a drop of oil on that. Make sure it doesn't need any extra lubing. And I'm just working that back and forth to make sure the oil has a chance to get in there. Let's look at this here because it's kind of crusty, but this looks like basically a spring arm that holds the tape head in place. So it looks like there's an adjustment screw to change the tension to move the tape head back and forth if you need to. So I was just poking there to see if we potentially needed to lube anything up there as well. It seems to be moving just how it should, so I think we will leave well enough alone with that one. And finally, up here we have the volume potentiometer, which is super crackly. So I'm going to spray some contact cleaner into that guy. Just work that in. So now get that put back together. Flip it over. Get this electronic. Alright. That's already less crackly, which is good. The audio's still got a bit of buzz in it, but so I think that's pretty normal for this. The motor seems to be working much better now. And, so you can see it's playing the whole card and it's rolling through smoothly. And it's funny because the old recording is now playing really fast because it's, now working at the correct speed. So let us re-record our test message here. Hello, check 1 2, check 1 2.
Check 1 2, check 1 2.
There we go. And that's way more legible. And again, there's a lot of crackle in here, but that's kind of part of the lo-fi charm of these, so I think that is to be expected. I'm going to try to clean this tape head, essentially just by running this card through with a bit of isopropyl on it. You can see that pulled off some junk on there a little bit.
Hello, check 1 2, check 1 2.
Testing. 1, 2, 1, 2. Testing.
Testing. 1, 2, 1, 2. Testing.
Okay, and that sounds a decent bit better after cleaning the head.
Testing. 1, 2, 2, 2. One, two.
Interesting. Just try to get down in there with the swab while it's turned off.
Testing. 1, 2, 1, 2. Testing.
Check, check. 1, 2, 1, 2. There we go, now it's running smooth. I'm gonna call this one fixed, because, you know, we could spend more time trying to make it less crackly or something like that, but honestly, that's kind of part of the charm of this guy. I think we've got it sufficiently functioning and cleaned up and ready to go. So what I'm going to do with this thing off camera, just 'cause it's not very exciting, but I'm going to try to hunt down some replacement screws to put it back together a little more securely. I'll either just grab junk stuff I've had or measure that one screw that it came with and go from there. I took a quick measurement before and I think it's like a 2.5 millimeter it looks like. Sometimes it's tricky finding things with the right thread pitch to go into plastic, since most stuff will be either like wood or metal screws, which are much finer. So I won't bore you all with that process, but basically I'll look for some more screws to put this back together, and then this will potentially make a return on an episode of the Super Circuit Bending Super Show. I think that would be a more appropriate place to relocate some of those switches or pots that I saw to the surface to make it a little more fun to play around with. And we could potentially do something like add in a filter, I think would be really cool, since I think the primary use of something like this would be for creating samples. So having an inbuilt filter I feel like would be really cool and handy for cleaning up noise or just in general making interesting sounding samples. But anyway, this will be it for Making It Work. Thank you all for staying tuned and watching this one. I know you hear it all the time, but if you haven't yet, if you take a moment to like and subscribe, that is greatly appreciated. It goes a long way in helping boost the channel and making YouTube show these videos to other people. And it also is just really motivating to see on my end, so it helps keep me motivated to actually keep making these and keep uploading them, since it's really easy to kind of lose steam on that sort of thing. And on that note, I do just want to say a huge thank you to everyone who has been subscribed and been watching and liking videos recently. It is, again, just a tremendous help. Appreciate everyone who has done that. I'll see you all in the next one, where we'll have a new project to try to fix and make work again. I'm not 100% sure what it's going to be yet. I've got a couple ideas floating around. But once I get that figured out and get that going, I'll see you then.